Hey everybody, welcome back. In this video, we're going to be looking at section 10.3, comparing two independent population proportions. So it's going to be looking at similar data as we did on the previous ones, except this time instead of having an average and a standard deviation, we're going to have just a proportion for each one, so a percent or a ratio. So for this, we need two independent samples that are simple random samples that are independent of each other. We need the number of successes to be at least 5 and the number of failures to be at least 5 for each of the samples. And growing literature states that the population must be at least 10 or 20 times the size of the sample. So we need a small sample relative to the population. Otherwise, we could have oversampling and cause incorrect results. We have really complicated formulas for these. We have chances for success and chances for failure, but this is actually the chance for success for part A and the chance for success for part B. And the good news is we don't need to get into too much of our calculations because it's very easy to program a calculator to run that for us. So that's what we're going to be doing in here, using a calculator that will run these for us. So two types of medication. Let's do an example. Two types of medication for hives are being tested to determine if there's a difference in proportions of adults who have reactions. So 20 out of a random sample of 200 adults are given medication A. 20 out of a random sample of 200 adults given medication A still had hives 30 minutes after taking the medication. So it worked for most of them, didn't work for 20. 12 out of 200 given medication B still had hives 30 minutes after taking the medication. So we want to test if there's a difference in the proportions of adults between the medications. And so I look and I notice 20 out of 200 and 12 out of 200, that seems pretty significant. Though we do want to test at the 1% significance level, so maybe that will, maybe we won't get to that 1% level. We only have a sample size of 200. If our sample size was a little bit bigger, we might be able to be more precise here. So let's see. So here are the calculations. And long story short, it calculates a p-value of 0.14. We have the proportion for success. So the first one was 20 out of 200 compared to 12 out of 200. So, 10%. And this was the portion of failure, wasn't it? So we had 10% still have hives and 6% still having hives. Here's how we write our hypotheses. So the proportion of A needs to equal the proportion B. That would be our null hypothesis. That means that's assuming nothing's changed. An alternative hypothesis would be the proportions don't equal each other. And you could write your null hypothesis as like this: PA minus PB equals 0. That's just the difference between the proportions would be 0. And here the difference between the proportions would not equal 0. So we're testing to see if there is a difference. And to do that test, it will be a two-tailed test. Here we can see the two tails. And together, those would add up to 14% or 0.14. So we would say at the 1% significance level, there's not sufficient evidence to conclude that there's a difference in the proportions of adult patients who did not react after the medications A and B. So we thought there was maybe a difference, but statistically, it's pretty common actually to get those results. So therefore, it's not significant enough. So we're going to be using this calculator where we just type in our proportion, the sample size, and the proportion of the sample size and our significance level. Then we pick if it's a one-tail or two-tail test. And then there we go. It gives us our p-value. And it tells us our results. So it's pretty slick. Here's a second example. And I did not make this example, so if you're offended by the concept of sexting, please skip this example. But this is written for college level classes, so that's why they have this example. A research study was conducted about gender differences in sexting. The researcher believes that the proportion of girls involved in sexting is less than the proportion of boys involved. The data collected in the spring of 2010 among a random sample of middle and high school students in a large school district in the southern United States is summarized in this table. And is the proportion of girls sending sex less than the proportion of boys sexting? So as we look here, we can see it's about the same. Sorry, my lights came off. Turn on lights. No, lights aren't turning on. Whatever. It's about the same number of boys or males and females, but there are some less messages sent from females compared to males. So what we need to do first is turn those into proportions. We'll write our hypotheses. So we want to test to see if the females are less than the males, or males greater than females, the proportion. Then our null hypothesis would be, do the females equal the males? So we're testing just one side, males bigger than, or males more than females. So this would be a left-tailed or one-tailed test. In this distribution, we're testing two population proportions, and the distribution is normal. Whenever they ask us about the distributions, you can always kind of just assume the distributions are normal. We plug this into our calculators. So I calculated those proportions just by dividing. So for the males, take 183 divided by 2231, and we get that proportion here. So it looks like about 8% of the males are sexting and about 7% of the females are sexting. Quite kind of high numbers, but whatever, I guess they're high school kids. Here's the 1% significance level. They tell us our p-value is 0.1. So quite high p-value. It's definitely not less than 0.01. So therefore, we would say this is not significant. So we do not reject the null hypothesis. So there is no difference between males and females. All right, that concludes this video. All right, bye.